Last tutorial, we created subnets that each had the same size. That is, they all had the same number of host bits in their addresses. In this tutorial, we look at creating subnets of different sizes. You may hear the term variable length subnet mask, or VLSM, when referring to this type of addressing. So let's quickly get into an example. For this example, we use the same address we had in the last tutorial, but our requirements for our organization have changed. This time we need one large network that can accommodate 80 to 120 PCs. We need a couple of other smaller networks which only need to handle 10 to 20 PCs. So how do we do this using this address which we've been given? Well, what we first look at is the largest network that we are going to use. So we need a network that will accommodate 120 machines. Well, what do we have to play with? We can see that all the network bits here on this side that we've been assigned, they can't change. But we can play with these host bits. And as we've learned last tutorial, we can borrow some of these host bits and turn them into network bits. So how many bits would we need if we were going to handle 80 to 120 PCs? Well, we look at the maximum number, 120, and say, how many bits would I need? So if I look at 2 to the n, that's got to be greater than 100. If I need 120 PCs, I need that to be greater than 122. Well, by trial and error, we can figure out that 2 to the 7 is equal to 128. So I need 7 of the host bits here. So if I look at this last octet, 1, 2, 5, 6, 7, 8, and we look at how we're going to divide that, we're going to divide it right here for this first network. So that all the bits, I need 7 bits here to number all my PCs. But this first or top bit here on the left hand side, we're going to use that for the network part. Well, since I only have 1 bit, I can only have 2 possible networks. So this bit here can either be a 0 or it can be a 1. Well, for our first network here, we're going to leave that to be a 0. All the other numbers in front here are going to be the same that I've been assigned, 190, 33, 45. This bit is going to be a 0. And now I look at my host bits. Well, for my network address, all the host bits are 0. So if I just fill in all zeros here, I will get a network address that is 190.33.45.0. So I'll just put a .0 here. What about the broadcast? Well, for the broadcast, all these host bits are a 1. And if I look at what this last octet is there, this is 127, 7 ones. What's my mask? We'll deal with this network later. What's the mask that I'm going to use for this network? Well, we had this mask before. That is all these bits here. They stay 1s, but now I've got this bit here, or this bit right here is now a 1 as well. So my mask is going to be 255.255.255 dot, and I have a 1 here with all zeros because the zeros because they're host bits, dot 128. So that's my mask. My network address, my broadcast. I could have a gateway which was dot 126. So that's network 1. So we check that off. Now, in the next network that we'll look at. We've already used this bit being a 0, so now that this bit now needs to be a 1. And it might appear that I can only create one more network, and that'd be true if I wanted to create a network that could accommodate 120 PCs. But I only need 10 to 20 PCs. So in this second network, how many bits do I need to use if I only need 20 PCs? Well, we'd find out that 2 to the 4 is 16, 2 to the 5 is 32. I need 5 bits. That could accommodate 32 minus 2, or 30 machines, which is enough to hold my 20. So I need 1, 2, 3, 4. All I need are 5 bits for my host. So in this network, I can actually borrow a couple more bits. I can borrow these 2 bits here. And these 2 bits, I can make 0, 0, 0, 1, 1, 0, or 1, 1. So I could create actually 4 networks. I only need 2. And I could use any of these combinations, any 2 of these 4 combinations. Typically we take the first couple. So let's look at setting these bits to 0, 0 right here for the first of our 20 PC network. How do we find out our network address and our broadcast? Well, remember we set all these to zeros for our network address. What number is this going to be? This number is going to be a 1 with all zeros. This number is going to be 128. So that's my network address. The broadcast has all ones. 1, 0, 0, 1, 1, 1, 1, 1. What's that going to be? Well, that's actually going to be 159. What's my mask here? Now, in the previous example, remember we were only using one of the bits for the network part, and so the mask was here. Now our mask is using 3 of these bits. So our mask is going to be 1, 1, 1 with all zeros here. And so our mask is going to be 255.255.255.224. And this is what we mean by variable subnet length mask. We have a mask here which is different than this mask here. They're variable or different. That's our address range. And so we could choose a gateway address for some number in between here, 129 to 158. And that is our first of these smaller networks. The second of these smaller networks, let me get a little more room to work. The second will use this combination here. Remember, we have to leave this a 1, so we'll have 1, 0, 1, and then for the network address we have 5 zeros for the broadcast. Our host bits are a 1. So 101 with all zeros is going to be .160. And 101 with all ones is going to be .191. So we'll review our network assignment here. We have 190.33.45 dot, and we're going to go 120, .0, 2.127 is going to be network number 1, and it's going to have this mask. The next two networks are going to be 190.33.45 dot, and we'll start at 128. Notice it's one more than this last network here. Dot 128.2.159. And the last network will be, these three numbers are the same, dot 160. Notice that's one more than here. To 191, so this is network 2, network 3, but these two have a different mask. They will have this mask here. So that's an example of variable length subnet masking, where we're creating networks of different sizes from a single address range. So let's see if you can do it on your own. Here we've got an example. You're given this network range. You've got to create 5 networks, 4 of which are small, 1 of which is large. I want you to design the network addresses that would be the most efficient as far as the host bits go. Don't take more host bits than you need. For the large network and 2 of the smaller networks. Pause this and then we'll continue. Okay, let's take a look at one possible answer. We're /24, so this is the network mask which we're given with this address range. We want to break it up, so we start with the largest network. We need 60 PCs, and we find that we're going to need 6 bits. 2 to the 6 is 64, subtract 2, I can have 62 machines if I use 6 bits. So we're going to look just at this last octet here. That's what we have to play with. Everything else here, we're not allowed to touch. I'm not allowed to touch the 150, the 35, the 24, because these are all ones in the subnet mask which was given to us. So we're going to borrow 2 of these host bits here. We only need 6 here, and we're going to say, I'm going to set those first to 00. Now, it doesn't need to be 00. It could be any one of 4 different possible combinations. We typically start with the lowest ones. That's why there could be more than one answer which will work here. But we'll set these to 00. This will be our first network. Now our host bits will range from all zeros to all ones. And so this is a .0, 1, 2, 3, 4, 5. If I have 6 ones, that goes to 63. So the very first network is 150.35.24.0 is the network address. The broadcast address is .63. We could set a gateway that was, say, .62 and hosts which were anywhere between 1 and 62. Be the first network. In our second network, we're going to take these 2 bits and go to the next sequence, which is a 0, 1. But we only need 10 PCs, so how many of these bits do I need? I'll redraw these bits. And we find here that we actually only need 4 of the bits. 2 to the 4 is 16. Subtract 2, 14. 14 is enough. So I only need this many bits for networks of 10. That means that for this 0, 1 pattern here, I can even take 2 more bits that we're going to use in our network. So I'm going to leave these to be a 0, 1, and I'm going to manipulate this pattern. I'm going to start with 0, 0. I'm going to then go to 0, 1. But this is the first combination of these 2 bits. So what are my addresses here? Well, I've got 4 bits. Network is all zeros. A broadcast is 1, 1. What are these as numbers in this last octet. 0, 1 with all zeros is a .64. And that makes sense because we started off with .63 for our last network. 1 with all ones here. If we work that out in binary, we'd find that is 79. So this network is going to be 150.35.24, and the network address is going to be .64. The broadcast is going to be .79, and all the devices are going to be numbers in between here. Now, one of the things we haven't done is said, what are the network masks? Well, let's go back here and look at our network mask. Our original was 255, 255, 255, but we're now in this network using 2 bits here. So our network mask for this last octet has 2 bits of 1 and the rest zeros. Well, this is, I know this is 64, this bit, this is 128. If I add those together, I'll get 192. So I know that my mask for this one here is, I can write it up here, 255.255, 255.192. So this is our network mask for network number 1. Network number 2 here, we're using 4 bits for our network mask. So as far as our mask goes, the first 4 bits of the mask are a 1, and then I have 4 zeros. And this network mask is 255.255.255.224. So this is the mask for network 2, and it'll also be the mask for network 3 because we're using the same pattern. So if we look at network 3, we can leave these 2 bits as a 0, 1 because we haven't exhausted all the combinations in here. We started with 0, 0. We'll now start with the next combination, which is 0, 1. And again, this could be different. It could be 1, 0 or 1, 1. So there's not any one unique answer. This is 0, 1 network. And so we look at the network address, which is all zeros, the broadcast, which is all ones, and what we get is .80. 0, 1, 0, 1, 0, 0, 0, 0 is 80. 0, 1, 0, 1 with all ones is 95. And so my third address goes from 150.35.24.80 to .95. Now we've got room for expansion. We'll notice that, oh, you need to create 4 networks. We needed to create 2 more networks, and you notice for the next 2 small networks, we could use the pattern 1, 0 in here, and then the pattern 1, 1. We also have room to expand because in these 2 bits, we haven't used the patterns 1, 0 or 1, 1. So that allows us some room to grow if we want to put in additional networks. So not only have we met our requirement, but we've also got room to grow because we've got additional networks that we could build in the future.